get started, welcome everyone. My name is Craig Shallahamer, and the title of this presentation is To Cue or Not to Cue? That is the question. Now, it's a strange title for a presentation, and there's a reason for that. It's because I want you to know cueing theory. I want you to experience cueing theory in your everyday life. Now, before we really get into this, I need to first introduce myself. My name is Craig Shallahamer, and I'm a long-term Oracle DBA, and I specialize in Oracle database performance. I'm also a performance researcher. I'm an avid blogger, and I'm also the author of a couple books that I'm really proud of. And I also do a lot of conference speaking, and I'm a teacher, and I'm a mentor, and I'm also an Oracle ACE director. Now I want to get into what this seminar is actually all about. A lot of people are surprised by this, but we live in a cueing theory world. We are immersed in cueing theory. You can't escape it. You might want to escape it. You're like a slave. You're going to be brought back. You cannot escape the world of cueing theory. And let me give you a few examples. Here's the old restaurant in the U.S. What's interesting about this restaurant, it is a perfect example of cueing theory. In fact, every time you walk into any kind of restaurant, kind of bizarre, but when you get into it and you start analyzing Oracle systems, that spinning is very much like being serviced. The service time related to cueing theory. And there's the wait time. That's the cue time. There's the service time. That's how long it takes. What's the big deal about predictive analysis? Well, anytime we can use cueing theory or just make predictions in general, our objective is typically to answer a fundamental question, and usually that question is about like uncovering risk, right? And so we want to see into the future. We want the first main topic, I'm going to talk about the relationship between work and time. It may seem kind of strange, but it's actually fundamental to understanding cueing theory. And you already, if you take a standard AWR report, you'll notice right up near the top of that, it's all about time. Right? In fact, I use this a lot because I do Oracle time-based analysis in my performance analysis work. And so I'm very familiar with this, and you probably are too, right? The top 5 of it. So that's the time focus. So where is the workload focus, the workload intensity focus? Well, if you just go a little further down on the report, you'll notice the load profile area. And on the vertical axis, that's the response time. That's the time it takes to process one piece of work, like one buffer get, one physical I/O, one. Now, in general, the response time chart shows us graphically the relationship between the work and the time, something that we know exists, but this is actually a more formal representation of that relationship in definitions. And I'm going to do this through a story in a way that I think that you will never ever forget. Okay, well, that's because I run a hamburger stand. In fact, surprisingly, I call this Craig's Hamburger Stand. And my hamburgers, they rock, man. They are awesome burgers. It took me 3 minutes to cook one burger. Okay, 3 minutes to cook one burger. So it kind of works like this, right? And we just cooked the crud out of that thing. And it only took 1 minute to go from a frozen burger to a tasty burger in a matter of 1 minute. We reduced the service time. We reduced the cook time. It's going to be 3 minutes. Well, 3 minutes, right? Their response time will be 3 minutes. The time it takes to cook one burger. So there's no queue time. You see, with queuing theory, there is always something that services transactions or services, right? Well, that server can be busy or not busy. And one way to measure the busyness of the server is called utilization. I'm going to use an example. I'm going to use a glass of water. So I have a glass right here. Okay, and this glass, you got your fixed capacity that was decided on the golf course. People start logging in, the requirements get higher, and pretty soon the requirements meet and exceed the capacity. The requirements start to just flow over the outside of the glass, the water runs down our arm, and it's a huge mess. And then our phone rings, and that's why we're employed as performance tuning specialists, right? As we'll see, response time, elapsed time, is not linear. That's correct, but utilization is. As Oracle DBAs especially, we can actually figure out the average operating system CPU utilization based on AWR reports. And I know that the CPUs on average are less than 50% busy. Boom, just like that, I can figure that out. And then from utilization, we go into the topic of response time. The whole setup of Craig's hamburger stand to utilization feeds right into response time. And response time actually feeds into the SQL statement elapsed time, which is what feeds into our user's experience. I'm going to increase the arrival rate. And you'll see as I increase the arrival rate, you notice the response time does not increase. It's the first time today there's an actual formula right here. Now, you guys are already set up. You know everything that is in that formula. You probably guessed. I've covered the fundamentals. You guys know some of the math. You definitely know the definitions. Now it's time to take it deeper. Now, with those in mind, which model only makes sense for a CPU subsystem and which model only makes sense for an I/O subsystem? Well, now what I want to quickly go over is the math, right? I've tried to save the math till the end here, but it's important that we do that right now. So the first formula is the utilization. He's essentially saying the service time is decreased by 20%, and therefore the utilization will also decrease by 20%. Okay? Now let's relate this to the response time. If we buy faster CPUs, what will we directly and aggressively attempt to change? Then I'm going to delve into how we actually use queuing theory today in both performance firefighting, tuning type work, and also with capacity planning and predictive analysis. And what you're going to find is that you probably are already using parts of queuing theory in your work, but you don't even know it. Not a trick question. If it takes me 1 second to take each piece of candy, out of the dish and eat it, how long did you hear that, right? The time it takes to process one piece of work. What is that? That's the response time. So queuing theory is built right into emptying candy from a candy dish, and guess what? That's also related to SQL statements, elapsed time. Queuing theory way of thinking comes out to around 2,700 seconds, 2,700 seconds, and how long it takes to process each little piece of work. And each little piece of work is a response time. That's related to utilization. That's related to the arrival rate. That's related to the number of servers. That's related to the service time. So it's kind of bizarre, but a user experience can relate all the way back down to things like the cook time and the number of stoves. That's practical. So when somebody says, Craig, how does this queuing theory stuff relate to reality in my job? I say, it's the candy dish. It's a candy dish. Now it's time to talk about how we use queuing theory and predictive analysis, which is what most people think about when they talk about queuing theory, but it's, as we know, it's more than that. So let me give you a scenario here. Easy, right? Will your system handle 20% more users? Questions like that. Will RAC improve performance? Well, with RAC, we're come to a close right now. And I think you can see that, the next time that you encounter a restaurant, you go get lunch, you arrive into the restaurant, you get served, other people are arriving at a certain arrival rate, there's a certain number of servers, you get served, you exit the restaurant. That's all queuing theory. Now, I don't think you're ever going to forget the Craig's Hamburger stand, and I hope you don't, because if you remember that story, you will remember the fundamentals of queuing theory. And next time you look at your smartphone, So that's what we're going to be talking about in this seminar.